Hello, everybody. Welcome to this month's Food and Water webinar, which is the sixth webinar in a series of 9 webinars celebrating the centenary of Institution of Chemical Engineers and discussing the future role of chemical engineers in addressing the key challenges facing the society. So the plan of today's webinar is a 90 minutes discussion. There will be a chance to ask questions by the audience. There's a chat box in which you can put your questions, and I will try my best to pass on these questions to our panelists. So just touching base, the food and water theme within the centenary, it discusses how the sector has been shaped by chemical engineers over the last 100 years. So chemical and biochemical engineers, they have made huge contribution to transform the global food and drinks and water industries to respond to the ever-growing requirements of the well-informed consumers. These developments, they include significant advances in areas such as food preservation and freezing, nutritional functionalization, low carbon and farm-free foods, cultivated meats, biomedical advancements, improving water efficiencies, water and food scarcities and safety. There are several other examples in which chemical engineers have contributed heavily within areas such as novel food textures, food products including chocolates, wafers, converting whey to proteins within dairy sector, or processing effluent streams for wastewater minimization and developing complex microstructure. So in the future, obviously, there's a global resilience which is required in terms of the supply chain of materials, products, natural resources, etc. So the chemical engineers, they played a significant role in ensuring we have safe food, safe water, clean water, and sanitation for the increasing global population, which has traditionally transformed the traditional role of food and water industries in providing safe and potable drinking water to the global billions to a more sustainable manufacturing technologies, providing more healthier, ethical, and environmental friendly solutions. So specifically, if we see in the current context of global crisis, wars, increasing energy costs, chemical engineers working within the food and water sectors, they have a very important role to play in developing sustainable water, energy, food metrics. And that is the basis of this webinar. It is imperative to highlight that the long-term sustainability can only be achieved through advancing novel technologies using chemical engineering processes. So today's webinar will highlight all the key challenges which we collectively as a society face within the food and water industries, and it will draw upon the diverse experience of our panelists, both within the food and water sectors, to discuss how chemical engineers of the future can play a vital role to address the complex mix of food, water, energy security issues. So to start with, I would like to introduce the panel. If I can please request the panelists to turn on their cameras. So we have on panel 6 eminent individuals from both food and water industry. Firstly, I would like to warmly welcome Rachel. Rachel is a professor. Professor Rachel Goins is a professor in chemical and environmental engineering with research into intelligent resource use in process environments, with a focus on water, wastewater treatment, water reuse, process manufacturing for emerging pollutants, pollution to water opportunities. She is also the head of Food Water Waste Research Group and lead for the University of Nottingham Interdisciplinary Research Cluster Waterworks. Rachel, very warm welcome to this webinar. Next, I would like to introduce Viknesh. Vik is currently Associate Professor at Swinburne University of Technology at Sarawak campus in Malaysia. His area of specialism centers on optimization of energy systems and supply chains. His research interests include design and optimization of net zero energy systems, synthesis of integrated biorefineries, industrial symbiosis planning, energy planning for greenhouse gas emissions reduction, and sustainable agriculture. Very warm welcome to Vic on this panel. Next, I would like to introduce Hugh. Hugh Thomas, who is a technical director and discipline lead for water treatment and supply at Atkins with 25 years in the industry. He has national responsibility for ensuring design quality, technical innovation and development, specializing in delivering optimal sustainable solutions that effectively manage business risks. He has worked in a variety of environmental research, design, and built contracting consultancy for the UK Water Company. Very warm welcome here for this panel. Andres is also a member of Atkins. He's a chartered process engineer with 5 years of experience. He specializes in the technical design and delivery of water, wastewater infrastructure, from feasibility to detailed design. It applies to both municipal and industrial sectors, primarily within the oil and gas. And Andres has worked on projects throughout the globe, and he's also a member of the ChemEng Evolution. So Andres, very warm welcome to you as well on this panel. Next we have is Petra Hanger. Petra is currently a lecturer in biochemical engineering, specifically like cellular agriculture at University College London. Petra is a biochemical engineer by training, and she has a PhD in stem cell biochemical engineering from Loughborough University. And her interests, they lie at the intersection between engineering and life sciences, with a focus on manufacturing strategies for cell-based products, addressing challenges such as food and nutrition by health, by advancing cellular agriculture, and healthcare by developing future therapies to minimize economic and social burden of aging population. Petra, very warm welcome to this panel. Next we have is David Pearce. So David, hello. David has worked for Fonterra, which is a large New Zealand dairy and processor and exporter since 1994. He has worked in a variety of roles, including as processing specialist, spray drying specialist, and in management roles. Most of his projects have focused on production and optimization of various dairy powders and drying plant efficiency improvements. David, very warm welcome to this panel, and I look forward to the discussions today. So just briefly introducing myself, I'm a chemical process engineer, and I've got almost 15 years of experience in projects, both within consultancy, design, as well as commissioning in food, drinks, chemicals, oil and gas industries. And currently I'm leading activities on ChemEng, specifically ChemEng 100 project, and chairing also the food and water panel. I'm also conducting research in renewable energy sector, specifically within hydrogen. So I would be really interested to hear your viewpoints today and discuss the key issues and challenges which are facing the food and water industry. So just to start with, I will request our first panelist, which is Rachel, to talk about the key issues within the food, water, and energy sector, and just highlight those key challenges which we as chemical engineers need to address. The second presentation will be from Hugh within the water industry, and the third will be from David. So starting with Rachel. Rachel, if you can please share your slides.
And to check, everyone can see my slides.
Yep.
Perfect. Thank you. So thank you very much for the opportunity to join the panel today. And I'm just going to be sharing a little about water, energy, food, or WEF. But I quite like the acronym FEW because it refers to the finite amount of these resources. And the many resources challenges that we face for food, energy, or water are about not having enough, or they're not being to the quality that is fit for purpose. And the other reason why I like this acronym FEW as opposed to perhaps WEF is because the challenges we face with food, energy, water, and considering the nexus often require considering the waste, or rather mismanaged or spent resources that arise from the nexus. So waste is not really a word, but it's one that we use, and it becomes an important resource itself, especially when food, water, or energy resources are dwindling, unavailable, or of poor quality. So when we manage the food, energy, water nexus and the issues from that, we need to also incorporate waste or the mismanaged spent resources. So that's why I quite like the few squared, where few resources becomes more. So there's many examples as to how to represent the few nexus. The strong interconnectivity between the issues of food, water, and energy. And the key idea behind the nexus is that each resource affects each other, the other. So a change in one will have an impact on the other. And this is also another recent few nexus example that shows that also the engineering needs, other disciplines, and the interdisciplinary workings in order to manage and address challenges in our few nexus. It also shows how the few nexus can bring together multi-stakeholders who historically focus on a single issue, and allows for approaching it allows for us to approach issues from focused perspectives. So the linkages between food, water and energy have always been present, but as pressure on the nexus grows, and with that the pressure can be exerted on one aspect or resource or multiple, the need for better understanding of the interdependencies between those resources becomes paramount. Now, chemical, biochemical and environmental process engineers play a major role in delivering sustainable solutions for food, for energy and for water and the nexus. And this role is not only in offering understanding of the connectivity between food, energy, water, but also in developing solutions and solutions that are practical. This requires systems thinking, so meaning the understanding of how whole systems work and systems within systems, nested systems, and generating engineered system solutions to meet desired targets. So iChemE defines nexus security as following under water, food, or energy security. And we all know that the demand for any of these resources is increasing and continuing, and this is occurring on a global scale, though the demand and the drivers can be country-specific and sector-specific. We know also that a growing human population places ever-increasing pressures on food, on energy, and on water. So if we take one perspective, such as our demand for food, we can see clearly that it puts increasing pressure on agricultural techniques, water resources, and land availability. This has then got that added layer of complexity because it's set against a background of deteriorating and indeed a changeable climate. So it's worth flagging that our needs change as well, and so our dependencies on the food, water, energy nexus and those individual and combined resources change. If we take meat and dairy consumption, in some parts of the world, it's now being seen that we want to be decreasing that from a sustainability perspective. In other parts of the world, our consumption of meat and dairy are increasing. So literally, how can our changing appetites impact not just on food, but then the energy and water requirements and the subsequent impacts and connectivities between? Note also that how we produce foods is likely to change. So there's likely to be an increase in laboratory-based synthetic foods. So one question is, how can we anticipate or forecast these changing demands and how they'll then impact on these individual resources and the few nexus? In that way, we can become adaptable and responsive to both internal and external pressures. So we already understand and indeed practice connectivities between different and several resources. This is water for reuse in food and agri being one. The 2017 United Nations World Development Report stated that an estimated over 80% of wastewater worldwide, and it increases up to 95% in low to middle income countries, is released into the environment without treatment. So by considering wastewater as a reuse, we have an opportunity to manage the few nexus and address impacts within that and to that. Now, Hugh will talk next and share more about water and reuse, but I thought I'd just flag very quickly two examples. This one is from Mexico City, where for 100 years, more than 100 years, they've been using raw wastewater for agricultural irrigation in the Tula Valley in Mexico. And in the last 10 years, Tonatiuco wastewater treatment process, which has a population equivalent of around 12 million, that's come into operation, and a portion of which is used for agri irrigation. And there's a lot of work, and you look at 2018, 2021 World Bank expressions of interest about how to look at wastewater reuse and energy and food connectivities. A further example is Singapore, which, though motivated by water security concerns, is an example considering the food, energy and water generation connectivity. So both Mexico and Singapore, and Hugh will share more from the water industry perspective, shows the few nexus is actually few squared, where they're each recognizing and utilizing waste to manage that nexus. There's also opportunities to translate expertise and capabilities between different sectors, for instance, from the food industry into water. I'm based at the University of Nottingham, so I've chosen local examples, but there's similar cases for water companies in the UK and in other countries. And so there's value in transferring knowledge from one waste stream to another and utilising the industry knowledge, for instance, on sewage waste treatment for crop mass and food mass. And this just shows water companies in the UK, large sites, use anaerobic digestion for managing biosolids, and they generate energy from this. But the photograph on your right also shows how one water company is translating that knowledge to other waste streams outside of the water industry, such as domestic food waste. And we need to appreciate that context and that solution for one WEF few nexus may not fit another issue. So we need to engineer solutions that understand the context or are adaptable to context. So following on with anaerobic digestion, taking waste to generate energy that can work for a large-scale treatment works, but may not be stacking up for dairy farms, for instance, or at least those in the European Union, given the number of cows and waste on a dairy farm. Note context. This may be different if we were in China. They have the largest dairy farm with over 100,000 cows. So this image is of the University of Nottingham dairy farm. And I'm just going to be finishing up with sharing one example of how we're working on the few nexus in this scenario. Cows produce a lot of waste along with what comes from them personally as cows, the waste milk, the washer from cleaning, from bedding. And Lyndhurst Engineering, in partnership with the University of Nottingham, has developed a technology called H2OD, where you're able to treat wastes and wastewaters to reduce the pollutant load, improve water and quality for reuse, while simultaneously generating bioenergy, and then a solids for fertilizer. And this was developed at hybrid traditional anaerobic digestion and microbial fuel cell technology. As we develop technologies, though, and we apply them to site, if we use this H2OD technology, this is, yes, on the University of Nottingham dairy farm and on other dairy farms. It also treats beer waste, ice cream manufacturing waste streams. Each of these feedstocks are variable and differing, and they all vary in time and space. So we also require tools that enable understanding how variable and complex waste resources can be better utilized and best utilized to obtain the best outputs with energy generation and improved water quality. And finally, we appreciate that the drivers today may differ tomorrow, and David, who will be our third talk, will expand more on energy, water and the dairy industry. However, if we take the dairy industry and net zero, where the activity is looking at energy mitigation actions to achieve net zero, if we consider only energy, this may lead to developing solutions that address net zero, but then subsequently impact on other resources, such as water use and quality. So addressing few nexus issue requires creating acceptable solutions, but in that self, what is acceptable today may not be acceptable tomorrow or in a different scenario. And even going beyond circular economy thinking and into industrial symbiosis, where our waste from one system or process in an industry become raw materials or a resource for another system. How can we do that to mitigate the waste spent resources and move towards that few squared concept? And going beyond net neutral and positive, which supports that industrial symbiosis. So to finish, from the ChemEng Green Paper, we understand that food, energy, water nexus is a key aspect of international development and a recognised problem. And our ability to consider all three aspects of that nexus together is essential if we want to make decisions about sustainability and future resource productivity and security. So chemical engineering, biochemical, environmental process engineering is well placed to do this and able to examine the whole system, the supply and value chains of natural resources. So by applying systems thinking to the few nexus, chemical engineers are able to offer insight into creating, sustaining and improving well-being for all. And with that, I'll pass on to Hugh.
Thank you so much, Rachel. Really good points raised. Hugh, if you can please share your slides. Thank you.
Is that coming through?
Yeah, you can see through. Yeah.
Great. Okay. Well, thanks so much, Rachel. That was really a really interesting overview. And as you said, there were a few pointers there into the sort of different areas of the food, energy, water nexus. I'm going to be sharing a few slides on chemical engineering in the water sector. There are some big topics involved in that, and hopefully that'll see some discussion further on. So just talking about food, energy, water nexus, we're going to zoom in on water a little bit now. And I think some of this information sort of reinforces what Rachel was saying there about how those sectors are so closely linked. So looking at across the globe, where do we use our fresh water and how much do we abstract? It does vary quite significantly across the globe from different continents and nations. But essentially in Europe, picking Europe as an example, 44% of the total freshwater abstraction is used for agriculture, 40% for industry and energy production, and that includes the food and beverage industry, and 15% for the public water supply. So those proportions do vary, and there are certainly other parts of the globe where the proportion for agriculture is much higher. Essentially, agriculture is pretty much always the biggest slice. The municipal water supply, the public water supply, the drinking water that we get through our taps, that tends to be the side of water, the water sector that most people see, and it's really important that we maintain the customer's trust in the quality of that water. It's got to be safe to drink, it's got to be good to drink. But there's also a lot of downward pressure on the consumption, the sort of per capita consumption, how many litres per head per day we drink or we consume and use around the house and home. But that's a little bit, I suppose that's all very important, but there's also a growing population, and so the effect of people drinking less or consuming less, using less around their homes and businesses is slightly offset by the growing population. And that causes, I suppose, that raises some challenges that I'll talk about a bit more in a sec. So, what do chemical engineers bring to the water sector? Well, in my view, and I think in the view of those that work in the sector, chemical engineers are pivotal to that journey towards sustainable water. Ultimately, treating water, treating wastewater, biosolids, it's a series of processes. Chemical, physical, biological processes. They're designed by chemical engineers and they're optimized by chemical engineers. And the same is true of resource recovery and the circular economy. The end game of treating the water to the right quality and the right quantity remains, but those opportunities for beneficial reuse, I suppose that shift that Rachel alluded to there of rather than thinking of wastewater treatment as a disposal exercise and environmental management exercise, it's actually an opportunity for resource recovery and capturing some of that benefit, whether that's energy or other resources, and closing that loop and bringing those back as a feedstock for other processes, the circular economy approach. So just going back to drinking water, so resilient and wholesome water supplies really a sort of a fundamental need of humans, and they've had enormous benefits over the last sort of century or so in terms of improving human health. And there are still a lot of parts of the globe where those benefits haven't been realised. I'll give a brief overview of Charity Water, which is the charity that the Water SIG supports and is affiliated with, which brings into focus the harsh realities of places where there isn't a safe and resilient water supply. But just going on to those water supplies, so climate change, population distribution and limited resources mean that often water is being transported over long distances. And in terms of managing drinking water quality, and this is a subject I spend a lot of my time thinking about, is we have to manage water quality right through from the source, wherever that source may be, whether that's treated wastewater, whether that's rivers, reservoirs, springs, boreholes, wells. We use a water safety planning methodology, and that's actually founded on HACCP, which is a risk-based technique founded in the food and beverage industry. But really what that's about is understanding where your source risks lie, what those hazards are in the source water, hazards to human health, hazards to customer acceptability, and managing those risks and controlling those risks right through to the customer's tap. Moving on to wastewater side and the energy and resource recovery. So again, Rachel alluded to some of those opportunities. The treated wastewater itself is a valuable resource in terms of irrigation, but and I don't expect everyone to sort of absorb this block flow diagram. But as chemical engineers and process engineers, we do like a block flow diagram. What this gives is just a flavour of some of the opportunities that are available from wastewater. So there's a lot of value in that wastewater in terms of energy, in terms of resources, and there are opportunities for beneficial reuse. So some of the sort of processes identified on here are very well tried and tested. So Rachel alluded there to the anaerobic digestion and release of biogas for energy source. There were other examples there of resource recovery. Some of those are well established, the food waste co-digestion and so on. So those are kind of in place and being optimized as we speak by chemical engineers around the water sector, and that's around the globe. But some of those are more art of the possible. You know, what kind of products and beneficial reuse resources are there in wastewater? And the truth is, there's a lot. So we can touch on some of those a bit later. But I think it's good to know that there's a lot of opportunity out there for chemical engineers to really make a difference and to help the water sector and the food and beverage sector and the energy sector move towards a net zero and a circular economy. So this is just an example of what a water company might be looking at in terms of their journey towards net zero. So Water UK published a route map for net zero in 2030, and the majority, so all of the water companies are working towards that target. And the kind of things that they're doing are looking at increasing that renewable energy production on site, procuring green grid energy, moving to low carbon fuels. One of the sort of inconvenient truths in the water sector is there are fugitive emissions from the wastewater treatment process. So some greenhouse gases are sort of involved in those processes, and understanding how those are managed, how they're quantified, and how they're reduced. That's one of the hot topics that chemical engineers are really kind of working feverishly on at the moment. So that was all I was going to say on the water sector. For now, and then we'll have some, hopefully I'll see some discussion. What I will do just before I hand over is just put a few slides up around Charity Water, so the WaterSig campaign for clean water with Charity Water. And I think, you know, amongst all of these opportunities for improvements to the sustainability and the circular economy of water and resource recovery, it's, you know, we should never forget that ultimately clean water and sanitation, it's a public health issue. And there are, as you can read there, 785 million people across the globe who lack access to that clean water. It's a really big killer. It results in more deaths than all forms of violence, including war. And every pound invested in improved water access yields £4 to £12 in economic returns. So it's a really worthy cause, and we strongly support that. And yeah, I encourage anyone to follow the link. And with that, I will hand back.
Thank you so much, Hugh. An excellent presentation, really highlighted key issues within the water industry. I look forward to discussing further. Can I please request our third panelist, David, if you can please share your slides and discuss about the issues facing the dairy industry.
Yes, I will, once I can figure out how to get my screen shared.
So we can see your screen currently, David, but it's not your slides.
Which one are you seeing?
Your webinar prep. A little bit behind the scenes. We can see your webinar prep in OneNote, so we've got a little bit behind the scenes there.
That's right. There we go. I'll try that one. Can you see the slide now?
That's it. Yeah, fantastic.
Yeah, we can see the slides now.
Good afternoon, good morning, good evening, wherever you happen to be. So I'm David Pearce. I work for Fonterra, we're a large dairy company in New Zealand, and I've prepared 2 slides just to give you a brief overview of who we are, because most people have never heard of us, and from that you should get some idea of the engineering challenges we face, and then another slide on some of the things we're doing to address those challenges. So Fonterra on a slide. So we, as a company, or rather as an industry, Fonterra dairying accounts for roughly a quarter of New Zealand's export earnings, and Fonterra is about 80% of this. So dairying is hugely important to New Zealand, and which a lot of people don't realise. As a company, we have about 20 million New Zealand dollars, $1 billion New Zealand dollars, which is about 10 billion pound. About 20,000 employees, but the number I'd like you to focus on is this one here. So in any given year, we collect something like 20 billion litres of milk and process that into a range of finished products. So 20 billion litres. So if you're thinking of a 1 litre carton of milk sitting on your breakfast table this morning, you need rather a lot of them. So New Zealand is, I'd venture to say, unique amongst dairying nations. We export 95% of the milk that we produce. This is, and 5% consumed internally. This is the exact inverse of most other countries who would export maybe 5%, if any, of their dairy as surplus and consume 95% internally. So we have a very large export market, and consequently we have a large share of the tradable commodities and tradable dairy products. So New Zealand as a country, I think, is responsible for something like 40 to 50% of the tradable dairy in the world. So that's the non-tariff stuff. So just in case you've forgotten about New Zealand, we're the country that Ireland managed to beat, unfortunately, on Saturday in the rugby. So this shows the distribution of our dairy plants. In the North Island, we have quite a range. This was the main traditional area. Relevant to this discussion, most of these sites are powered by, have gas-fired boilers because we have gas reserves over here and reticulated gas supply. The South Island has grown significantly in the last 20 years as a result of irrigation, particularly in this region here. But there is no reticulated gas here, so these sites are coal-fired, which, needless to say, is giving us some headaches and challenges. So 19 and a bit billion litres of milk was turned into just over 4 million tonnes of product last year. So that covers the full range: milk powder, skim milk powder, whey protein powders, milk protein concentrates, cheese, butter oil, etc. So we cover the whole lot. We've got about 25,000 farms and farm workers and about 4.1 million cows in New Zealand. So it's roughly one cow per person, or sorry, 0.8 cows per person. Oops, wrong way. So I put the slide in, I called it our seasonal reality. So on the x-axis here is the progression of the dairy year. So this right on the origin is August, working through October, January, April, and back to August. And the milk flow increases obviously as you get to spring and into summer. Grass grows, cows eat, they calve, etc. So you get a lot of milk. And then as you come over into December, January, obviously it dries out, and each one of these different coloured curves is a different seasonal milk flow. Now, the thing I'd like you to take away from this is the difference between this point, or rather this point here, and this point here is a factor of 20. So when nothing's happening, we've got maybe one factory, perhaps two, ticking away, producing milk into just to keep the farmers going. Oops, sorry, bother. Here, which we call the peak, we have 20 times the milk flow. And that means that every asset we have is working, and we are then constrained by how many assets we have, how much they can process, and what they can process. So a milk powder plant can make milk powder, a cheese plant makes cheese, and if the market is screaming out for cheese and you've only got milk powder assets left, then that's unfortunate. So as you can imagine, at this point of the year, everything's running, and as you build up the curve, slowly you bring plants on, and as you come down the curve, you slowly take them off. And some of you will be thinking, well, that's not very sensible from a capital perspective, and in fact, you're quite right. It's not very sensible at all, but that's unfortunately our reality. And that's also compounded with things like daily cleaning for a lot of our plants. You have to come off for a CIP, as we call it, clean in place, which can take between 2 and 3 hours. If it's an evaporation plant, it might be 12 hours if you're doing a dryer, which you probably do every 3 or 4 months. So that's the sort of the background to Fonterra. So what are we doing about to address some of the sustainability problems? So clearly, you know, we've got, I think I said 25,000 farmers, so they've got lots of cows, up to 4 million cows. That's, as our previous speakers have shown, that's they drink an awful lot of water. They create an awful lot of waste. So our farmers are not idle. They don't particularly like being pilloried by the press. So they're very busy separating stock from waterways. There's a lot of riparian planting. We're minimising waste spreading by various techniques, some of which we've already had discussed. And cows are responsible for a large percentage of New Zealand's methane emissions. And our research centre has come up with a product they call Cow Butcher, obviously modelled on the fermented kombucha product, which is very popular, and which is a bacterial system that modifies the gut flora of the cow, and which means when they belch, they produce less methane. So that's something we're definitely working on. Carbon footprint is particularly important. When I was looking through this, actually, I noticed that the United Kingdom is not represented on this chart, so I wouldn't like to guess where you sit. However, from our perspective anyway, the important thing is New Zealand is very low, in fact the lowest in terms of kilograms of carbon per fat protein milk equivalent, which is the unit across the bottom here. And obviously you can see different countries have different milk footprints. So I think Ireland's in here at about 1.07, Australia 1.06, so, and Peru with 3.34 is the highest of the ones that are presented here. So you can see quite a range, but our farmers are very efficient, and they also have a very low carbon footprint. Now part of that's because New Zealand, a bit like Ireland, lots of grass, cows just wander around outside and eat it. There's no feedlot, particularly no feedlot system as a rule, so there's no cut and carry, which incurs significant carbon. As a company, we have our own climate targets, so a 30% reduction in manufacturing emissions by 2030, net zero emissions by 2050, and no net increase in greenhouse gas emissions from dairy farming between 2015 and 2030. So we're making reasonable progress against those targets at the moment. So the part of the industry I'm in is in the manufacturing side, and we obviously have a number of initiatives underway. We're clearly not sitting on our hands. Coal to biomass boiler replacement is a big one. What people don't often realise is biomass boilers, you can't just nip down to your local Tesco and pick one up and pop it in. They're very expensive. You're looking at several $1 million per megawatt generated, depending on where it goes in and what the fuel is. And the waiting list for these devices can be 18 months or 2 years. So it's not a simple thing. However, we've committed to get these replaced, so we are working hard to do that. Energy reduction is obviously large, and spray drying is a very large user of energy, converting milk into powder. And so we're actively looking at projects that reduce the amount of energy required in the spray drying system. Our previous speakers have talked about water reduction, and some of you might be aware milk is about 87% water. So we have programs in place on a number of our sites, particularly the water constrained ones, where we're using RO and other systems to recover a lot of the water that comes off particularly during the evaporation process of making milk powder and making whey products and so on. So we're definitely very active in that area. And these of course come with their own issues. You obviously can't just run an RO system. You've got to make sure the urea values are low. You've got to make sure the microbial quality is adequate. So when you reuse these water sources, they don't contaminate your plant. As with most parts of the world, local authorities are becoming tighter and tighter in their requirements, and as resource consents come up for renewal, the expectation is that we and other dairy companies will meet those. So that requires often significant capital investment. Packaging is something we're very aware of. We use something like 19 million, I think, bulk bags and 25 kilo bags for our milk powder and other powdered products. Roughly 87% of our packaging is recycle ready, as we call it. So there might be a paper outer which you can use, or a plastic liner, and those are recyclable. We say recycle ready because often countries we export to do not have the infrastructure in place. And I think I'm aware in somewhere near Malaysia, I think Unilever was putting in a very large recycling facility that would allow a number of people to contribute to that. And obviously we run a large number of tankers, 40-ton tankers, to collect our milk, and so we're in the process of electrifying those as we go. And the last point I make is, so Fonterra's emissions, we're roughly 20% of New Zealand's emissions, which is significant, and 90% of that comes from on-farm, so that's from the cows themselves. So although we are owned by our farmers, we do not own our farmers. So we're working with our farmers rather than dictating to them what they need to be doing in order to meet the requirements and get their emissions down. And 10% of our emissions come from manufacturing and transport, which I've sort of described here. So that was all I wanted to present, just to give you a flavour of who we are, what we do, and what we are doing, and why our situation is perhaps of interest here. So thank you, and I'll call it quits.
Thank you, David. Thank you for your presentation. We already have questions coming in. Can I please request all the panelists to turn on your cameras? Thanks, guys. Some really key issues raised here. And one of the key things which I would like to straight away highlight is the key question before we jump into the focus question is key question that has been asked by one of the panelists, Sayuruddin Mohammed, and he says, like, in terms of the link between the food, energy, and water nexus to UN Sustainability Development Goals, what do you have to say in that, and why, as a profession, like, if we are to evolve, it needs to be aligned to the UN Sustainable Development Goals. Obviously, Rachel, you highlighted the key issues of food, water, energy nexus. Here you also talked about the reduction of energy, etc., and water utilization, recovering resources. And David, you mentioned similar issues within the dairy sector. So before we answer this question, obviously, before I ask one of you to start answering this question, I think I would like to straight away address it is like the basis of the webinar is obviously food, water, energy, but as well as, it is linked to the sustainable goals of United Nations. So it is not only focused in biofuels or primarily within energy reduction. So I think just to put you on the spot, Rachel, if you can please answer this question, how do you think we can link these key issues to the UN Sustainable Development Goals, which we discussed in your presentation today?
So the United Nations, and I did briefly allude to one of their reports in 2017, but they also have a report from, I believe it's 2021, where there's been more and more a clear focus on, we have these sustainable development goals, we understand and appreciate the food, energy, water nexus, and then looking at how they interlink. And off the top of my head, but there's a lot of documentation online, and this report that I'm referring to, there's like clear 12 SDGs where the United Nations take those and marry them to the waste, energy, food nexus and look at what the connectivities are between them. Equally, I mean, there has been work done by the United Nations where they've taken, for instance, water as a resource and said water literally runs through all of the SDGs. So there is work already being done, led by the United Nations, appreciating that the food, energy, water nexus is inherent to many of the SDGs. I think to sort of answer how we can do more and what we can do, I think some of it comes back to, you take any one SDG or you take any particular scenarios change, context change. So it's appreciating for that particular situation that we have, what might be the solution? How might it impact on other systems that we are aware are connected or might not even at the moment be connected? And so it's building up that picture. Obviously, complexity runs through.
No, I think that's well said. Hugh, would like to add something to this?
I think from a water sector perspective, I think building on what Rachel said, the UN guidance and the way that's been interpreted, certainly taking a sort of Water UK perspective, the UK water sector represented by Water UK published this route map around the journey towards net zero and sustainability, and the companies that own and operate these assets that are moving towards using more resource recovery and energy recovery technologies. So I think it's been interpreted and underpins the business planning of the water sector, certainly in the UK, and I see that in other parts of the globe as well.
Great. Vic, how do you see the situation in Malaysia, like just bringing perspective from other side of the world?
Oh yeah, I mean, I agree with the panelists that have put out the points earlier. Certainly, I think food, energy, water is very interrelated, they're interlinked. And I think to answer the question about the UN Sustainable Development Goals, the thing is, as long as we look at it from the few perspective, as how Rachel presented earlier, I think we're already addressing a lot of elements in the Sustainable Development Goals. It's just that perhaps that it's presented in a very different framework, and in that sense, I think in Malaysia, we do see a push in this area as well. We do see a lot of initiative towards a net zero targets. We see circular economy gaining traction now. We also look at reducing wastage and so on. So yeah, certainly the movement is there as well. And we see a lot of companies are looking into that direction too as well in Malaysia.
David, can I bring you on this because you were the last to present on this?
Sure. Yeah, look, in the dairy industry, we're exceptionally proud of being able to contribute to two of those goals, the zero hunger one. So, I mean, that's what we do. We provide food to people, and a lot of our exports go to Asia, to the Middle East, to Africa, and along with other dairy companies, we're targeting our offerings to what people can afford. So, you don't sell a very high protein product into the middle of Africa where people have almost no money. You create a modest protein level, which gives them enough nutrition that they can afford for the price of a day's work almost. So we're really proud to be doing that, improving the nutrition, but that also leads to the good health and well-being goal. Sorry, I had to look, you caught me on the hop with the UN targets, so I had to use Dr. Google to help me here. But ensuring healthy lives and promoting well-being, you can't do that if you don't have good nutrition. So I think those two are really intimately linked. So that's where we contribute.
I think very well said, David. Healthy life and nutrition, and if it is not affordable, you don't get nutrition, right? Petra, I think I will bring you in this at this point because you do quite a lot of work in cultivated meats, etc. So I think if you can bring your perspective on this and how we can align the key issues to the UN Sustainable Development Goals.
Yeah, of course. I mean, cell agriculture is a newly emerging area, so there's still a lot of work to be done in this area, and there hasn't been that much research yet, but we know, or at least we theorize that actually quite a few of these issues will be addressed through cell agriculture. So I'm not sure if the audience is very familiar with what cell agriculture is, but it's essentially a way of making products that we are all very familiar with. So things like meat, things like milk. It actually even includes leather, because it is an animal-derived product. But the way they are made is without the animal itself. So it's basically through industrial biotechnology techniques and methods. So I guess in terms of linking cell agriculture with the Sustainable Development Goals, there's actually quite a few that I think would be addressed. So obviously zero hunger would be one of them, because the aim is to produce the same animal-derived foods that are nutritious, that are healthy. So and actually because you would be producing them in a controlled manner without the animal, where the control is not as defined as it would be by using biotechnological techniques. You can actually improve the aspect of nutrition. So I guess that would link to another sustainable goal, which is the good health and well-being. It also addresses the climate in the sense that because it wouldn't rely on the use of animals, the greenhouse gas emissions that are associated with animal farming would be less. Obviously, there are some contradictory studies on this because, as I said, because it's such a new area, the actual production of these type of products is not fully defined yet, or it's still immature. But I think one thing that the industry is really doing now is being aware of all the issues and trying to draw from aspects like utilizing waste, so bringing that circular economy in, trying to minimize the waste production, trying to minimize the risk of disease transmission. So all these issues that are associated with animal agriculture in particular, I think the cellular agriculture industry is trying to address all of these. Actually, one other SDG that I haven't addressed is responsible consumption and production as well. So obviously, by producing these without the animal, you would be touching on that.
Thank you so much, Petra. Andres, you worked in different parts of the world on water projects. Obviously, Hugh has touched on sustainability within the water industry. What's your opinion on this?
Yeah, so just to firstly mention that I feel like a lot of people don't realize the direct impact that the water industry has in emissions, but I think from memory, the water industry produces about 3% of the CO2 equivalent emissions around all industries, which is quite a significant amount. But just to provide a bit of a perspective from a different part of the world, where a lot of my experience comes from, which is in Australia, they are at the moment one of the LNG producing companies, one of the leaders, and they also want to become one of the green hydrogen global leaders. And obviously hydrogen is one of the main topics of discussion when it comes to net zero, and for, I think, obvious reasons. But something that at least I didn't realize until quite recently is the water demand that requires. So the water demand for hydrogen production is about 9 to 14 kilograms of water per kilogram of hydrogen. And just to put in perspective, when Australia was first at least starting to look at the production, to meet the target hydrogen, which wasn't sort of a massive amount to start with, but I can remember the exact production rate, but the water demand to match that was greater than the domestic water demand of the entire country. So it's just, again, just to compare that nexus, it does really highlight how connected these two are, because obviously if the world is going to rely on green hydrogen to meet that net zero, but there's not enough water there, then that's obviously a key restriction.
I'm glad you raised this point, Andres, because it's so critical. Like, it's so easy to forget, like we are trying to move towards net zero, trying to minimize energy, looking for alternative energy vectors like hydrogen. Obviously, I'm doing some research in this area as well. And it's very critical to understand the impact of other industries. So just to keep the conversation flowing, what I would like to do is I have a couple of focus questions which I would like to raise so that we generate those ideas. In the meantime, I would like to request our attendees to kindly raise any questions you have, and I'll be happy to pass it on to our panelists. So the first question which I have is on we have already discussed some of the issues in terms of the complex mix of food, water, energy, but we will talk more about the energy security. So as we discussed, like food, water, energy security, that is going to be a significant matter for the global population. Obviously, in the backdrop of different issues we are facing, i.e. the climate change, pandemic, conflicts, etc. So without strong intervention, it's only going to get worse. And specifically, if you're trying to align, as we just discussed, the objectives of within both food and water industry to the UN Sustainable Development Goals, it's very critical because we need to see, like, the impact it has on, say, for example, crops and farming as well. So the question is obviously how can chemical engineers of the future they can contribute to address the challenges posed by this complex mix. So just starting again back from Rachel. Rachel, you highlighted resource recovery, you highlighted different issues within the within the food industry, and just how you can't just see it on its own. It's all interrelated, food, water, and energy. Can you please address like how chemical engineers in future, like what innovative methods, etc., like they can contribute to address these challenges?
So I think the first thing, and you mentioned there are other considerations like climate change, and then these sort of unknown unknowns like COVID-19, what's going on in the Ukraine, so appreciating. So there's two things here. I think, first of all, contributions predate on the realization that these resources, energy, food, water, they can't be considered in isolation, and they're intrinsically linked, hence that nexus. And I think the second thing, that when we think of a system and systems thinking, we might appreciate this as the system, but that then has impacts on other systems, so there's nested systems. So in terms of contributions that can be made, in addition to that systems thinking is, in no order, there can be the technologies. So technologies that support not just focusing on addressing a particular point or issue in a sector or a resource, but then looking at how that can make sure it's most energy efficient, reuse spent food or water resources so you can have energy generation. So it's holistically thinking our focus, whether it's because that's the sector we're in or that's the main driver, take the net zero concept. Yes, we can address it and work on it, but the technology, in 5 years, 10 years, 15 years time, will that technology still be fit for purpose, or will it be having other impacts or unintended consequences on other resources? So I think looking at technology development and being aware from the outside as we move up technology readiness levels, it might be looking at reduction of that particular pollutant, but why don't we equally consider that pollutant is a product, for instance, and can then be used as a fertilizer? And I mean, Hugh mentioned this, the water industry in many countries is looking at we're not a wastewater treatment process, we're a resource recycling facility. I think alongside that is then also contributions can be made, and this is part of systems thinking, is looking at modeling and analytics that support systems thinking and the interactions between. So machine learning and artificial intelligence models, so you can fit and predict resource use, reuse, and interactions. I think especially when you've got multiple outputs. So where one output might be pollutant reduction, that might be COD, that might be total suspended solids to increase water quality for reuse, whilst another output is bioenergy generation. So there's further complexity here as well, because you have multiple pollutant production, multiple energy, and what works in one sector or for one waste, you would then want those modeling and analytics tools to be able to then adapt it for variable waste streams, different sectors and sites. Life cycle analysis, so you can evaluate the environmental impact of a product through its life cycle. And I think also underlying architecture, like cloud manufacturing, which will facilitate industrial symbiosis. So where the cloud manufacturing model is the concept of sharing manufacturing capabilities and resources on a platform in the cloud, so you can make those intelligent decisions to provide the most sustainable and robust manufacturing routes available. And that considers not just manufacturing facility, as David's discussing with Fonterra, but also his work and his company will obviously be considering how it's then exported, 95% exports to the other countries, so that the whole supply chain as well, and then how that might feed, or you might be able to utilize the resources you've got for other industries as well. So it's ensuring that you have a global perspective, that systems thinking, and a combination of technologies to tools.
That's really good point, Rachel. Just trying to bring systems thinking to this. And I think you mentioned about AI and machine learning things to reduce, energy consumption, or reducing the issues related to the consumption of resources. So I think similar things in water industry as well, isn't it, Hugh? What is your perspective on this? More digitalization, AI, and the issues which we can bring to the table. Can you please?
Yeah, I think that's very true. I mean, in terms of the water industry, as with other industries, we're on a sort of digital transformation journey, and that's not just for my part, I work on the sort of design side and the planning side, so the digitalization of design, but feeding through into the kind of construction, operation, maintenance, and sort of optimization of assets. It's a really hot topic, and it's fair to say there is already a lot of automation and not artificial intelligence, but if you like, systems are controlled with intelligent systems, and a lot of automation, as in any other industrial process. So we're kind of not starting from a position of going from sort of fully manual to fully automated. But I think those opportunities around AI are really great in terms of predictive operation, looking at what's coming, in the sort of short or medium term, and adjusting systems. And Rachel was alluding there to, kind of using production capacity or manufacturing capacity in one area when it's available. I think that sort of, making better use of existing assets through digital tools and automation, it is very much the direction of travel.
Yeah, I think some really good points here. I would like to bring Vic. Vic, what is your perspective from Malaysia? How things are moving within the food and water industry, your experience in terms of IE process integration, artificial intelligence, etc. How do you see things moving forward?
Well, it's a common practice here to look at energy recovery and also industrial symbiosis. For example, like the palm oil industry, we see a lot of applications of industrial symbiosis practices over here, which is related to circular economy in that sense. You see palm oil mills connected to a biogas capture system, which treats waste and generates biogas, and that produces electricity as well. Then we also see palm oil refineries as well, situated in the same location, processing the palm oil into further refined products as well. So certainly this is an area, but I think going back to the question on how chemical engineers can contribute in the future in this area, I do echo what Rachel mentioned about modeling and data analytics. I also like to highlight there are some challenges which chemical engineers need to be aware of in this area, particularly because in some parts of the world, data is not readily available. Let's be frank. So that is something that we need to be aware of, when we take note of that. And that's where our ability to make informed assumptions and, data processing and collecting or benchmarking data is going to be very crucial. But there is another point that I'd like to raise, which probably is a bit unconventional here. When we talk about the role of chemical engineers in the future, the first thing we would think about is engineers going into the production line, or being a design engineer, and all these conventional job scopes in that sense. I see that with the urgency coming along the way right now, the jobs are slowly evolving, and the roles that a chemical engineer plays is also evolving in that sense. So I would say that in terms of addressing this, it would be nice to have chemical engineers working as policymakers as well, or joining the policymaking team, because we see this in a very unique perspective. Looking at this, as how Rachel put it, they're all interlinked, and we have the engineering know-how, or at least the chemical engineering know-how, and linking them together. So having people in the policy-making area gives a better perspective into developing policy in those areas, because at the end of the day, when it comes to policy, there's a lot of other elements behind it. Number one, it's the cost element behind it, is how much is it going to cost? And the second thing is, this is something that I've come to, study quite frequently in this past few months, is something called just transition. What just transition is that when you transition over into new practices or into a new way of life, you must also take into account that you should not leave people behind. So whenever you move to a different industry, or you make a difference in the industry, it's always important to also take note of the people that who might lose their jobs, the social component behind it, the impact towards the society, and that's a very crucial part as well that chemical engineers need to look at when they address this issue as well. Yeah.
Thank you so much, Vic. I think really good perspectives. Petra, I would like to bring in you. What is your perspective on this?
Yeah, so I guess thinking from the perspective of foods and novel foods, sustainable foods, so things that are covered by cellular agriculture. In terms of the technologies, I think Rachel and Hugh were bang on. In the future, we will need the same predictive modeling, AI. I think those would be technologies that would be very useful for this industry as well. I think because it is such a new industry, and it is quite specialized, particularly thinking on the cultivated meat production. It draws a lot from areas like tissue engineering. Even though I guess the things that the industry are trying to figure out now is, and they are figuring out now, is the fact that tissue engineering and cell therapy, gene therapy, all of these techniques, they tend to be quite expensive. They are obviously appropriate for those type of applications, but in the area of cultivated meat, we are trying to produce food. So I think what the industry is realizing now is that it needs to be, the manufacturing processes need to be somewhere in between tissue engineering and drawing from the food science and food manufacturing practices. So there's a lot of work going on there, but in terms of future technologies, there's definitely a need for predictive modeling. There's definitely a need for new analytics, maybe even new bioreactor designs, depending on what type of cultivated meat product you would want to produce. So there's a lot of gaps there, a lot of opportunities, I guess, in terms of for future. I guess one other thing that I would like to touch on, and Vignesh started, is skills training. So particularly in tissue engineering, cultivated meat space, because these are quite related, you do need quite specialized skills, and unfortunately there aren't enough training programs out there to tackle that. And the industry is actually seeing this issue now. So I think one thing that will make this industry sustainable in the long term and successful, hopefully in the long term, would be skills training for sure.
Thank you so much, Petra. I think you highlighted a point which was discussed in one of the webinars we had earlier, was on chemical engineering education, and I think skills training is really key. So thank you for highlighting that, because we can discuss about what are the steps we can take, but if we don't have people who have the right skills to address those issues, I think it will be all just talk. So I think thank you so much for raising that point. David, I would like to bring you in just very quickly before I move on to the next question. Is like, what do you see like from the dairy industry perspective in New Zealand? Like, do you do any kind of predictive modeling or things like, use of digitalization or artificial intelligence, etc.?
We do for control of our plants, definitely, and we have a program looking at what's called digital twin systems, which is, as far as I can tell, is dynamic process modeling by any other name, as a way of controlling and getting our plants to where they get to go. But I think while that's good, you hear the hesitation in my voice. As a company, and I'm sure our dairy colleagues, we're very good at optimizing plant. So we get delivered something from an equipment supplier, and we can optimize it to death pretty much. But I don't think that really addresses the problems, does it? Because then you're still making a particular product, and we can look at water minimization by changing the way we do things. We can see, do things like changing our cleaning practices as much as we can, extending run lengths, and so on. And we can use sensors to detect interfaces. In energy side, we can use heat pumps, pinch recovery. God forbid we tell our senior managers what thermodynamic minima look like, because they really hate to hear about that. They want to know that you can generate something from nothing, but that doesn't really solve the problem. I think if you get your energy and water use minimized, then you survive as a company. And for us, we're, as I said earlier, we're providing nutrition to a good percentage of the world who need it. And if we go under, then these people are going to go hungry. So that's also, and someone else may step in, of course. But so keeping our own house in order is I think is really key to surviving. And for us, that's our food security. But if I could make a couple of points, food safety is really, really important. If as a processor you start to optimize your energy, optimize your water use, and that can lead to shortcuts, and that will frequently lead to disasters. And if engineers are not working with their process microbiologists to make sure our wonderful savings are not putting food products at risk, then consumers are at risk, and that's disastrous. So there's an interesting tension there. But engineers of the future, I don't know whether AI will fit in this for our industry to the extent that it does for others, but we're looking at novel processes that will deliver essentially the equivalent nutritional value and product performance at a lower carbon footprint. And for us, product performance and nutritional value are so important, because that's why people buy dairy products. They don't buy it because it's got protein. They buy it because the protein is good for them. And so we're using an approach called S-Pro Squared, which has come out of ETH and Zurich, with Eric Windhardt leading it. And so that's a way of integrating chemists and engineers and food techies to design the structures that you need in your product. And by doing that, you actually optimize your raw material use, and therefore by definition, you're starting to minimize energy and water use and maximizing security.
Thank you so much, David. I think it's really key, like integration of different disciplines to address the key issues. One of the questions which we received on the panel is obviously, what are some of the interesting food and water projects which some of you would be working in to address the sustainability issues at the moment? Andres, maybe I can raise this question with you. You're working on a couple of water industry projects as well. So if you can give any examples or something like which you are currently working on, that would be great.
Yeah, so okay, I'll touch on there's been a lot of talk in from the previous panelists with regards to energy and water reuse, just to optimize the industry. So I'll just touch on three. I'm just gonna mainly discuss the water reuse, just because the energy side is probably gonna come later in the conversation. But there are these. I'm gonna again talk about a different side of the world, and this time is the Middle East. So which is where I've been mainly working over the last few years. And in this case, I'll draw on three main points. Which is water reuse in industrial purposes, for industrial industry, in municipal clean water, and in municipal wastewater. So in the Middle East, it is now a requirement of many of the oil and gas companies to produce a water optimization study. So that's kind of looking at ways to actually maximize your water usage and minimize the disposal of water, which I think has been, from my understanding and talking to the more senior staff of oil and gas clients, it's definitely been a growing demand. So one of the projects that we worked on over the last year was using petrochemical waste for multiple petrochemical sites and refineries that produce very nasty water that would normally be disposed outside or incinerated, and we produced a 20 different process project that managed to convert this water into high purity water which is demineralized water used for boiler feed water. And that had a recovery efficiency of about 75%, which meant that what was known to be as a waste product, by all these different treatment processes, you managed to recover 75% of the water to a really high quality. So that's in industrial purposes. Some of the other ones that we've been working in some significant municipal wastewater treatment plants in Saudi Arabia, a lot of the sites are required to produce water at a standard that can be reused for agriculture purposes. And that seems to be the trend going on around that part of the world, which, obviously they have a very high water scarcity. So I think it's a good step forward. And the last point in clean water, which I think a lot of you may know, that obviously, for example, Saudi Arabia has a quite significant lack of water. So they're using this major RO desalination plants, and that is great in the sense that it alleviates the problem of clean water, but it also produces this wastewater. So there's a lot of, and at the moment, chemical engineers are looking a lot into this reject, because when you produce water from the sea, you're going to produce a reject, which is where all the salts are highly concentrated, and that is then disposed to the sea, which could potentially increase the salinity if it's a smaller catchment. So there's a lot of work at the moment by chemical engineers in order to reduce that waste and potentially achieve what is called zero liquid discharge, and reduce that water reject as much as possible. So those are some projects.
Thank you so much, Andres. There's a general question from Ian. He talked about chemical engineering solutions do not inherently address fundamental needs for sustainable population and sustainable economies. So obviously we need to think more broadly. So I think he's touching base again on broad system thinking. Rachel, you've already mentioned about system thinking. Petra, you mentioned about the skills training, etc. So is there anybody who would like to take this question and answer that? Probably either of you. Rachel, would you like to answer this? Or
can you just clarify the question, please, again?
Well, the question is we all realize that only the solutions which we discussed, they do not address the fundamental needs of the population. So we need to think more broadly. I think we talked about systems thinking, obviously, so do we need to think more out of the box, rather than set structured programs for chemical engineers, etc., which address the needs of the industry?
That's a heck of a question, isn't it?
Yeah.
I would almost start by saying that the premise of that question, and it's a really good one, an interesting one, it was about, we're not addressing the needs of the population. What is the population? It changes in time and in space. And if I was to say perhaps that had some of the challenges, and where, for instance, we have so much waste, we have to deal with the waste legacy, has some of the challenges that we now have and that we need to address based on the fact that we have been responding to needs and concerns and demands of the population without appreciating or realizing what the impacts of that might be. And maybe this touches a bit with what Vic was saying here as well, in that as process engineer or any individuals that are working on research and translating it into actual practical solutions, understanding the role of, yes, policy making, but also in communicating what this might mean and how this might impact. so that we're not a sort of a responsive to the needs and the demands of a population, but sharing what that might mean if this is what your interests are. So yeah, and I think I'll let somebody else speak, because that's quite a question.
Yeah, Petra maybe, and Vic thereafter. Petra, can you please go first?
Yeah, I mean, it is quite of a hell of a question. It does make you think, though. I think the only thing that kind of comes to mind, because obviously, you know, I work in the cell agriculture space, and I guess it's more of my familiar area, my comfort zone. I think what I could say is that it is about the systematic approach. I think for the future we would need, well, there is this crazy idea going around, which I guess this is the area to go fully crazy, because it's still something that is being developed. But there is this idea of, you know, developing future self supporting manufacturing facilities, whatever shape or form these would take. Maybe you know, it wouldn't be a manufacturing facility for foods, animal-derived foods in the true sense of what we know of it like now, but it would be something, I don't know, a box in your kitchen, or, you know, like one of those food robots, but essentially would be feeding on sustainable energy, would be using waste products, maybe, I don't know, coffee pods, or, you know, coffee filters or coffee waste, that sort of thing. So I think it would be, yeah, those would be the kind of things that in the future could address all of these issues, but would also play on the population needs, because obviously it would provide those nutritional foods, but at the same time would minimize that sort of damage. But I completely agree with Rachel. I think we shouldn't necessarily think about the population demand. I mean, the needs, you know, we all have the same needs. We all need foods, nutritional foods. We all need water. We all need energy for everything that we do, in that sense. But, you know, perhaps the actual population demand for certain things is what has been driving all of these issues that we are seeing now. And, you know, I'm particularly thinking, obviously, again, going back to my comfort zone, on the demand for meat. Which, you know, meat is a staple in many cultures, and perhaps in certain countries it is actually a sign of I don't know, of development, right? But we all starting to see now that meat produced as it is now through industrialized animal farming is, you know, is not sustainable, and it comes with all these other issues. So, you know, perhaps it's not about addressing the demands necessarily, because that's what has led to some of these issues, but addressing the needs. It's still, you know, in sense of nutrition, nutritional food, water, all the basic needs. I think it's still something that needs to be designed, needs to be thought of. And thinking out of the box is what we do need to do, I think.
Thanks so much, Petra. Thank you. Vic, very quickly, a few points from you, and then I will move on to the next question, which is on water industry.
Sure. I had to write down some of my points before I forget them. Yeah, it's an important question, and I think in order for us to look at these solutions, I do agree with the premise of the question. I think we have to look at the needs, because I was listening to a forum. I just can't recall what the forum's name was, where they talked about, you know, if you're going to go with all this kind of new transitions over, the most important thing is that we need to put money in places where, or in populations where they really need it. Only then they can see the importance of all these transitions, or all these new areas of considerations that we're looking at. What I mean is, like, if we're going to transition to renewable energy or into all these other new practices, you know, people may not be able to see the significance behind it if they are poor, you know, because for them the necessity is they want, you know, clean, fresh food for them and nutrition for them to survive the, you know, the next day or so. So by addressing this kind of issues, certainly we can even address the other issues like the food, energy, water nexus. But the point I'm trying to drive here is it's extremely important for us chemical engineers to work in a multidisciplinary approach with other scientists, with other people from various backgrounds, because only then we'll be able to synergize a solution towards addressing this issue. So yeah, I'll keep that short. Hopefully that was sufficient for us to move to the next point.
Thanks so much, Vic. One question which I have, which I want to bring in very quickly, is on the water industry. Like obviously, with climate change, population shift, and the need for resilient, wholesome drinking water supply, it can result in more integrated water supply networks and water being transferred to longer distances. So what role chemical engineers can play to ensure a safe and resilient drinking water supply? So specifically on drinking water supply, and I think I will ask this question to you because you touched base on the water charity and the various projects undertaken by Atkins. So yeah, if you can please chip in on this one. Thank you.
Sure. I mean, I was listening with great interest actually to the sort of previous discussion around, the sort of needs of population, and I think this is a sort of the need for safe and wholesome drinking water, is absolutely a need for the population. And what's happening in a lot of parts of the globe, and I'm sort of more familiar with what's happening in the UK, but I know it's happening elsewhere, is we've got population growth. We've also got population density kind of polarization. So in the UK, our sort of highest population densities in the southeast of England. So the availability of resources of freshwater resources, that a lot of the parts of UK and Europe and North America and plenty of places around the globe are over abstracted. So the use of fresh water is sort of unsustainable. So those aquifers or those rivers, they're over abstracted. So really it's those kind of three things around population growth, climate change, limitations of supply of sort of raw water resources. That is in a lot of places meaning that we have to move water further. We've got to take it from where it's available to somewhere where the population lies to meet the needs of the population, to provide that safe and resilient water supply. So, and that you could look at that just as a hydraulic challenge, an energy challenge, because it's heavy stuff. I'm working on resource. I mean, there's a lot of work that goes on around water resource planning, looking into the future of 10, 20, 30, 40, 50 years hence. What is population going to be? Where they're going to live? And essentially, where's that water available? And I think just dipping very quickly into a point that Vic raised, which is around the influence that sort of chemical engineers can have, and where best to put that influence around policy and strategy. And I would say that my most rewarding work is exactly in that space, because it's my firm belief that the answer to a lot of questions that policymakers pose comes from chemical engineers, because we understand the food, energy, water nexus. We understand the carbon emissions associated with electrical energy, the opportunities around resource recovery. So if we aren't feeding that to policymakers and strategists, or if we aren't at the table, then I think that's a missed opportunity, and the likelihood of unintended consequences or maybe going down blind alleys is significantly higher. So I really I think that's one of the most stimulating and rewarding parts of being a chemical engineer, is getting that space. So just going back to water supplies briefly, so there are resource options in the UK, resource planning in the UK, which involve over the next sort of 25, 50 years moving 1 million tons of water per day. More water, 1 million tons a day of new water into the southeast of England, and that's a lot. You can imagine there's a lot of energy associated with that. There's a lot of treatment, and so where do chemical engineers fit in? Well, it's not just about quantity, is it? Water, it's a public health issue, so it's got to be the right quality. So chemical engineers, we've got to understand, what's the source of that water, what are the hazards of that water, and I talked about the water safety planning approach in my slide deck earlier. A lot of that water may be recycled wastewater, it may be coming from other sources with greater risks. So understanding those risks, tailoring the treatment required, optimizing the treatment, identifying the lowest sort of cost and carbon way of treating that water, and then maintaining its quality on its journey down from in England. It's in the northwest where we've got some water down to the southeast where we haven't. It's going to take a while to get there, and it's not going to be maturing like a fine wine as it wends its way down to the southeast. So effectively, managing things like corrosivity of the water. We've got a lot of old, as in a lot of sort of older parts of the world. There's a lot of lead piping in properties and buildings, and so we've got to think about corrosivity of water, plumbosolvency. We've got to think about maintaining the microbiological quality. I think, David, you mentioned the importance of maintaining the quality of that product. Water is effectively a product, and it goes straight to the customer's tap.
Thank you so much, Hugh. Yeah. I think really good points raised, and I think very linked to the food and dairy industry as well. So David, obviously, within the dairy sector, you see these issues. So it's some couple of points from you, and then probably, I'll just try to close the session. We are already nearing the end time.
Sure. So we have water for two parts. One's what the farmers use, and one's what the processors use. So the farmer use is I can't really speak very much to that, so I'll politely park that, and hopefully no one will ask a question on that because I won't be able to answer. But for a processor perspective, yeah, definitely we have many of our sites are water constrained, so we have limits on how much we can bring in, and that gets us to the reuse that I talked about. Milk is 87% water. If we get a good chunk of that back when we evaporate, and we do have reuse programs in place where we do try and reuse as much of that water as we can. I don't think we have any sites which are net zero, but that's definitely something we're thinking about and how we can achieve that. So we would use it for water flushes, for treat it, and use it for cleaning, which is where a lot of our water goes. If you have a large evaporator, it's using 50,000 litres an hour of milk when it's running. If you have 4 of those going, that's 200,000 litres an hour. When you're doing a clean, you're running probably 50% more in your cleaning cycle, so you may be up to 300,000 litres an hour for several hours. That's what's that? That's 600,000 litres that you've just about to drop down the drain. As part of your cleaning system. So that's where a lot of our focus is on, and how we can reuse that, chemical recovery, water reuse, and so on.
Just one point which one of the audience, Seamus raised, like population demands. Is that governed by people or companies? What do you say, Rachel, and then Hugh? Maybe one perspective from food and one from water industry.
Apologies, say again, Amit.
Sorry, the question is from Seamus, and he mentioned about like the population demands, we talked about demands from population and driven by the population demand. Obviously, Vic also mentioned about it's not just because people requirements is the basic requirements. They are not thinking about all those fancy solutions. So how is it interlinked, like in terms of like either it's governed by people or by the companies? So that's the reason. One perspective from you and one from Hugh. That will be great.
So I think the point there about population demand. I mean, first of all, I think Petra summarised it clearly about the needs and the demands, and we might say it's population needs, but are they needs or are they demands? And I think the appreciation that you've got multiple stakeholders as well, of which the population, the receivers of these different goods that use water, energy, food, they are also stakeholders as well. So when you're talking about having the demands of a growing population, you're focusing, and there's been a lot of work just focusing on water. The IWA have been doing this. Certain countries and organizations like Singapore has done a lot on this. It just becomes more complex if you're considering any particular country or sector, and then the multi-resource perspective of energy, food, water. So how to manage, address the demands of a growing population, or the demands of population. I think it's bringing them into the conversation. It's that appreciation of, to have this product, this is what it is. So if you're looking at, you know, for a cup of tea, the water footprint is that. So if we're looking at buying something, whether that's a meat or a milk from our supermarket, whichever supermarket that might be, it might currently have the calorific value and the fat content, but also the resource input as well, how much energy, how much food, how much energy, how much water to give that food product, for instance. So I think it's building that conversation. It's back to communication, isn't it? To policymakers or to the population.
Yeah, Hugh. Thank you.
Yeah, I think you know, certainly the per capita consumption, you know, of the population. There's an enormous amount of work that's gone on in you know, and certainly in the UK. You know, I see it around the globe around trying to reduce that number. So, you know, the number of litres per head per day is a number that's, you know, at the forefront of every kind of water company's mind, and they are, you know, incentivize their customers to reduce that. And it, you know, the UK, for example, has gone down a lot in the last 20 years. You know, maybe from 150 litres per head per day to 100, their target is 115, so it's a, you know, big drop. And, you know, businesses and companies, you know, David talked about the water recycling within, you know, within the dairy process. You know, every industry it's obviously in their interests, and I think the, you know, the wastewater reuse. Andres touched on a point earlier about, you know, in Saudi Arabia, you know, a lot of the water is desalinated water, so that ultimately they've created fresh water from seawater, so that wastewater, you know, recycling that wastewater for irrigation, you know, it would make perfect sense, because it's, you've invested in making it fresh, you know, keep using it basically. But I suppose that, you know, the other side of the seesaw is population growth. So you can reduce your per capita consumption, but if your population is going up, your demand is still going up, which is why, you know, in the UK we are, you know, we've got to bring more sources in.
Yeah, thank you so much. Just a very quick from everybody, like one point which Tyrone he made is like, do you think we need to go back to an integrated global economy to address these challenges? And how would you make the system robust enough when there are certain economies, he gave example of China, to basically closing the borders, and so certain economies, they don't want to integrate with the global economy. So how do you address all these challenges? Starting with David probably, and then I'll go around very quickly.
I was afraid you're going to start off with me. It's a nice one to warm up on, isn't it? We definitely see that with because we're large exporters, so we intensely feel the changes. So when Shanghai port was closed for a number of months for COVID, that created no end of problems for us. I'm inclined to think that no one country has the brain power to solve these problems on their own. I think you really have to have some sort of integrated view. And I mean, that's where organizations like iChemE and AIChemE and so on come into their own, because, you know, we've got members everywhere and we can tap into that skill set. So it's not quite answering the question, I don't think, but I can't see how you can do it on your own, I suppose.
Yeah. Just very quickly, Vignesh, any closing remarks you have on this?
I would answer this question in a way where I answer my students. It's always good to start somewhere, you know. So whether is it integrated with the world or not, I think it's a matter of urgency, I would say. So it's always important for you to start somewhere and figure it out from there, you know. And I think that's where the opportunities lies. And actually, as chemical engineers, we tend to do that at times, right? We start somewhere, we build on that building block. And if, regardless of what kind of economic system that we employ on a larger scale, I think the key point is that the driving factors was to start somewhere. And whether be it in a company, like some of our, you know, our colleagues over here have done, or some on the policy making scale, or even some in the research scale, at the end of the day, it's important for us to get something started first, and then use that as a driving factor to keep going and integrating eventually, I hope, you know. So
thank you. Andres, any closing remarks you have on the global perspectives and, you know, how we can address these challenges?
Yeah, I just think at the moment, if we focus around the three different water, energy, and food, I think it's safe to say that we are already in an integrated economy. Obviously, you can see the energy what's happening at the moment with the whole Russia situation. Obviously, that was the energy source that was redirected across the globe, and the impact that it has, and that's why, you know, some of the fuel prices have skyrocketed, causing devastating, you know, consequences across a lot of Europe because of that specific reason, because it's integrated, and, you know, obviously if one of the links breaks, then that affects, and you can see that across, obviously primarily across the food and energy sectors. I don't think the water sector is as prominent, where you would share the water across different countries. I have seen it in the Middle East where they have done it, but yeah, just to conclude, I think that's something that is already happening. But what we could work on is just to improve it from how it is.
No, that's great. Thank you so much. We have already reached the end of the time, and we are actually 10 minutes over the time. So I think I have to give a close here. And so thank you so much, everybody, for your time. So obviously, we discussed some really important issues, role of chemical engineers, how it's evolving, how in terms of the policy making, chemical engineers need to be more involved, use of artificial intelligence, digitalization, systems thinking approach, integration of different disciplines, and obviously, as Vic, you said, put money in places where, i.e. in terms of, like, you know, poor people or people are looking for necessities. So, you know, addressing those and then trying to bring people on board to address the sustainability and other issues within the food and water industry. So there's a lot to take. There will be a reflections piece after this webinar, which will be on the website. So thank you so much, everybody, for your time today, for participating in this debate, for taking our time from your busy schedules. It was really nice to have you here and discuss all these key important points. Just before I close, I would like to mention that there is a webinar on built environment and transport, which is next month in August. The details will be on the website, so please do ensure you register for that as part of the monthly webinar series of ChemEng Evolution project. So thank you, everybody. Enjoy the day. Beautiful sunny day outside here in the UK and wherever you are in New Zealand, Malaysia, and cheerios. Thank you.
Thanks, everyone. Bye-bye. Take care.
Thanks, everyone. Bye.
Thank you, everyone.
Bye.
Bye.